Problems on Newton's second law of motion. Problem 1. Basically, we are using the second law of motion to solve these problems. What force would be needed to produce an acceleration of 4 meter per second square in a ball of mass 6 kg? So, there is a ball 6 kg in weight and a force is being applied, F, to move this ball on a ground. Let's say with an acceleration A, which is given as 4 meter per second square. We need to find the force that is required. We know, given our mass of the ball M is equal to 6 kg and acceleration A is 4 meter per second square, and we know from Newton's second law, force F is equal to mass into acceleration, which is 6 into 4, 24 newtons. Go to the second problem. Calculate the force required to impart to a car at a velocity of 30 meters per second in 10 seconds, starting from rest. The mass of the car is 1500 kg. So a car is moving on the road starting from rest. That means U is initial velocity is 0. Now it is moving and acquired a velocity of 30 meters per second in 10 seconds. And the mass of the car is given as 1500 kg. Let's find what is the force that is required for the car to acquire a velocity of 30 meters per second. So given mass of the car M is equal to 1500 kg and the rest, because it is starting from rest, initial velocity U is equal to 0 and it acquired a velocity V, which is 30 meters per second in time 10 seconds. We need to calculate the force, and from second law of equation, force F is equal to mass into acceleration. Now we do not know what is acceleration. So A can be found out from the given parameters as V minus U by T. Since we know first equation of motion as V is equal to U plus AT, which is nothing but 30 minus 0 by 10, which is 30 by 10, 1s, 10 3s, 3 meter per second square. Applying this in the force equation, we get F is equal to mass as 1500 and acceleration is 3. So this becomes 4500 newtons. So we'll see next problem, problem 3. In this problem, the net force needed to bring to a stop in 2 minutes a 200-ton train traveling at 24 meters per second. That means a train is traveling at 24 meters per second and its weight is 200 ton and we need to bring it to a stop in 2 minutes. So the given parameters in this case are the mass of train, 200 tons, which we need to convert into kgs. So, which becomes 2 into 10 to the power 5 kg. Since 1 ton is equal to 1000 kg. Now we need to find the acceleration to find the force. So the given parameters for that are time 2 minutes. That means 2 into 60 seconds as we need to convert into seconds. And the change in velocity, the delta V, change in velocity is from final velocity, it has changed to initial velocity. So U is 0 and V is 24, which is minus 24 meter per second. Here the minus sign indicates a backward direction. It is stopping. Now we know the force F is equal to m into A, and here A is change in velocity by time taken, which is minus 24, by time is 120, which is minus 1 by 5 meter per second square. So applying the mass value and acceleration value, we will get 2 into 10 to the power 5 into minus 1 by 5 is equal to 20 into 10 to the power 4 into minus 1 by 5, which is 5 fourths. So minus 4 into 10 to the power 4 newtons. So the force required to stop the train in 2 minutes is minus 4 into 10 to the power 4 newtons. And the negative sign here indicates force is in the opposite direction of motion.